Thanks, Rich, for helping us further set the stage for our discussions today. So next, I'd like to introduce another member of our core forest soil moisture team, Dr. Russ Briggs. He is a distinguished teaching professor and has been teaching soil science courses at SUNY College of the Environmental Science and Forestry since 1995. He's currently the director of the Forest Soils Analytical Lab, and he also serves as the director of the Division of Environmental Science at ESF. Russ has been working with the U.S. Forest Service and forest soil moisture monitoring as a volunteer for more than 5 years. He is a critical part of our team. Russ, sorry, and I said Rich, apologize. That happens all the time to us.
Thanks, Stephanie. It's great to be here. It's been amazing to watch this group develop over the years. And it's funny because I have some colleagues and so I've been heavily involved with carbon. I said, what do you do with soil moisture? Carbon's where everything's going, all the money, and little did they know. So I have to remind them of that. So it's kind of neat. Right. So I'm going to start with the first slide of every presentation I've seen this week. We hold these truths to be self-evident. Right. Can I admit? Let's see. There. Oops, let's see. I guess it's down arrow. Oh, yeah, let's see. Oh, thanks. Thanks, Mike. I'm an old guy, right? I should be able to figure this out. That's why I have a lot of students in classes. Okay. Maybe not. There, just down there. Okay, thanks. All right, I'll try again. So soil moisture data, it's got to have it, right? And so us et al, everybody forever, and it was soil moisture is one of the 50 essential vital variables considered by the by FAO. Cool. So current knowledge. So I was going to look at current knowledge, just a little bit of a review of current knowledge and needs and gaps. So current knowledge, and I marvel at all the ag papers, right? And the using drones and doing site-specific management on almost on a centimeter basis, and having soil moisture be able to retrieve that way. But it's a little more difficult, I'd say, in forests. We've got the microtopography, right? And we also have, as Rich mentioned, these O horizons and these other horizons, and we have these wavy boundaries and kind of some complex fingering and all this interesting way of this morphology, right? And our rooting depths are all over the map, so we can't just concentrate on the upper meter, but they range from nil to very deep, right? And so those roots are really extracting. Here's a picture. This is one of Jim Boyle's students, is Guillermo Tronsko, and this is at near Bob Power's LTSP site, one of his LTSP site north of Oakhurst. And Guillermo's pointing to mycorrhizal roots. Okay, and so this is the kind of depth. And the same kind of thing in Southern Oregon on some different mineralogy, but the same in these mixed conifer forests, mycorrhizal roots down here in fractured bedrock. Okay, so this is just a huge expanse of depths and the things we need to consider when we're thinking about applications to forest management. And then we have, of course, the very shallow soils. We have the range. So the range in soil depths that we're dealing with across this landscape are phenomenal. All the way this up at Cranberry Lake, one of our students during the summer session, one of our little spots, we do some soils. And so then we think about the range in sites and exposure, and we go from upper hills, very exposed, wind, rain, ice, and so forth, all the way down to the valleys. And then you superimpose on that the microtopography, right? And so it's not just upper, lower, and middle slopes, then it's complicated upper slopes, middle slopes, and various combinations. So the physical site data for these are just an amazing range of width. And so where do forests grow? It's where they grow well and where people wouldn't plant. And so this gives us this huge range that we have to kind of cover. Okay. And then the parent materials, just superimposed on that, the parent materials, and we have everything from till and outwash. This is a great source of outwash, a great source of road building materials. It's a nice shot up in Maine, up across an esker. And then, of course, we got these very deep alluvial soils, and most of those go to ag. This one actually was unfortunate. There was a beautiful hybrid poplar plantation there. It was about this big in 4 years. I think it's 40 feet tall, and that's now development. I guess that went to housing. Okay. And so what does this mean? So thinking about movement of water and soil moisture, it's extremely complicated because of the flow of water, the saturated flow down following the saturated gradient is messed up or mixed up. So a simple one-dimensional model doesn't work. And so we have layers, and there are different rates of penetration and flow across horizon boundaries, and then across impermeable layers, and then in fractures. And so it's a pretty wild system, thinking about the range going from a fairly easy to describe root zone to a zone of the critical zone, all the way from the top of the canopy down to the bottom of the roots and below. Okay. And so then we have the canopy. We've got canopy heterogeneity. We have difference just alone in hardwoods and softwoods, and difference in respective areas of transpiration, of evapotranspiration, different rates of capture with conifer systems, and greater range of evapotranspiration and interception. So the incoming infiltration is altered. And so ET infiltration. So this and the species. And so this dynamic on top of those other three just makes the situation of us trying to interpret soil moisture a bit more complicated. Okay. And there's my illustration of hardwoods and conifers. So the implications. And so the implications, as I think about this, surface soil moisture is really, it really doesn't do the trick for us, right, to meet forest management needs. And as we've seen through many presentations, there have been some really nice papers looking at deeper depths, some of these down to 150 centimeters, some parsed in 5 and 10 centimeter increments on some very intensive. And so those are the types of things we need. But not only that, but the fluctuating water table, that perched water table that's very flashy, that drives a lot of when you can be on soils and when you can be off soils. So I've been advocating to add to this system of measurements, piezometer system, just a simple piezometer to track the temporal nature of the water table, because that has such an effect on what we can do in management. And so our knowledge gaps, infiltration ultimately, and then change in storage and outflow. And so we had with the presentation of our Newhall model with that water in, water out, and trying to parse that. And so add that third dimension now. So this becomes a pretty challenging problem. And here's one, hats off to Claudia for describing this the other day, operations just in terms of rutting. And she did a really nice job of talking about rutting and the impacts and what we have to worry and keep machines off. She looked at the plastic limit. And so that extra added a little piece. And here's operability. Here's that water table. Here we are in the cedar, and all of a sudden your machinery disappears. So Laura Kennefic says, why'd this happen? And she said, we didn't have any moisture monitors. What would have been nice and helpful, I think, is just tracking that perched water table. And that makes the big difference in the capacity of these sites to support machinery, and wouldn't have to fish out the harvester. So the needs, I think about looking at the bright spots. So the big push now on the new soil survey, the idea of these dynamic soil survey properties. And so I think that seems to bring a new foundation or perspective. Right? And so the dynamics of that system, it's just kudos to my colleagues in NRCS for kind of starting to bring that view around. And now it's the big buzz. Okay? And then the other thing we talked about, scaling, going from kilometers to decimeters, right? So this is the level, our thousand, kilometers, and just under these types of variability, range and variability, from exposure and parent material and depths, and then the complex mixture of those, it doesn't allow us to work on kilometer scales, right? So the scaling down is important. And I was really heartened to see some of the efforts on a couple of papers yesterday on scaling, looking at the in between trees. And that was pretty heartening. And with that, so I think about, do we need a new paradigm? So I just think we have the paradigm. It's the landscape soil paradigm. But if we superimpose that with this idea of a water budget landscape soil paradigm. And instead of just thinking about a soil map, a static soil map, thinking about a description of a system where water flows through the system and kind of tying that to landscape and soils. I think that's the new wave, the new answer. And so all these things are moving that direction. All the papers that show us these amazing capabilities, machine learning, the 4 methods of machine learning that were described yesterday, and some of the things that Stephen had talked about with his company. It's just amazing how this is taking off. And so with that, so looking forward, so where are we headed? So there will never be enough sensors. There will never be enough sensors. And Carlos, he put in as many, and there's just not enough time. There's not enough money. There's just not enough resource to do it. But these advances we're currently developing in monitoring, machine learning, modeling, remote sensing, and someone brought up yesterday, we're the social scientists. The social scientists bringing the public and to bring in the distribution of this knowledge to make it more palatable and make it more wanted and supported. So this could get us there. And it seems to me that based on what I've seen these past couple of days and the development of this group, and now with the full involvement of U.S. Forest Service with Northern Forestation, it seems to me we're headed in the right direction. And with that, so I think we can get there. I tend to be a glass half full kind of person rather than glass half empty. Even though I do a lot of administration, I've tried to maintain the glass half full. And so we can get there. And I think it's going to be with coordination and cooperation that we've seen, that Cindy's described and others have described, that we're moving forward with. And with that, here's a nice shot of an early morning bike ride in the Adirondacks at the Ranger School reunion a few weeks ago. Nice way to close. It's the rising of a new dawn. We have a lot to look forward to. And with that, there's a lot more collective wisdom in this room than I even have just a tiny, tiny piece of that. So with that, I'll open that to any kind of questions and discussions. Thanks.
Okay, and with that, before we go into our next session, let's take a few minutes for questions. Does anyone have any questions for Cindy, Rich, or Russ? Marena has a question.
I know it's a little, maybe a little early for this, but what are you guys thinking about in terms of connecting with state foresters? Not to mention.
I'll direct that to Cindy. She's been doing a lot with that.
Oh, yes. So there are several groups of convenings of state foresters. The one that I have engaged with and have gotten a lot of commitment towards these joint efforts is the Western states foresters and regional foresters within the Forest Service called WFLC, Western Forestry Leadership Coalition. And we just had a gathering a few months ago. And this is one of the things that I go around and socialize. I talk about, I bring up in meetings of the importance. And I like to share, as I'm looking over here, NIDA supported and NOAA supported efforts to trial and test a format that's been used in COCORAS successfully, but to format it with this particular questions to be able to assess forest conditions. So how are things that we're observing in the forest changing, just like the COCORAS deployment across agricultural lands, because that's missing. When you look at the drought monitor, it paints the entire country, but it doesn't really differentiate very well those things that we're seeing in forests, which are on a different time scale than agriculture. So there's one brief mention of a very vague and not very specific fire risk status. So I'm not going to steal your thunder. Look forward to that this afternoon. So that's an example. But yes, they're on board, Colorado State Forester. In fact, next week or the week after, I'm looking to Stephanie, we've got a whole group of congressional folks whose names you would well recognize visiting Colorado. And one of the presentations that will be done there by the Rocky Mountain Research Station directors, my peer over there, will be about this work and the importance of soils and soil moisture monitoring and all the work that we're doing around soils. So yes, I hope that answers the question. Thanks, Marina.
John, and then we'll go with John. And then we'll move on to our next part. Go ahead, John.
Hey, Russ, I have a question for you. So you seem to have a vision for what a soil map unit or a series of map units may look like in the future. Could you describe a little more in detail about what that would be?
So I think about a soil map unit now, rather than just you add on the parent material and the general location, it would be I would imagine a portion that describes in better detail the saturated flow conditions and in terms of relative to some kind of topography going up and down. So I just imagine that, and instead of NACIS just being just having the database with a set of chemistry and physical variables, that reference to saturated conductivity might be another piece of that, and add to the interpretation table, and on a landscape basis within going up from top to bottom slope rather than just this little pixel.
And then one last question with John Bolton in the.
Yeah, thanks. So very encouraging to hear all of you come together and talk about the importance of soil moisture. I wanted to get your opinion on, I guess, the role of remote sensing, and wearing my NASA hat, and land surface modeling, and where you see, if you can share some examples of some successes or even highlight some potential areas of improvement that we have in both of those.
I'll give that one to Rich. Or Russ, would you like to?
I'm actually,
Rich is like, no. Russ is like, no, Rich can get that one.
I'm not the expert, but what I do know from reading in literature, obviously the canopy's getting away. And the talking, I know Mike Kosh has been working a lot in forests. The litter layer, the O layer is also an issue. And then the other limitation, Russ was talking about, looking at surface soil moisture is not giving us the story in forests. So, so I don't, that I'm hate to be down on it, but I think that on the other side of the coin, a remote sensing can really, using trees as a phytometer kind of thing, that that can confirm what we're seeing in the soil, that the trees are stressed or something like that. But
Yeah. Let's talk about more of that during our panel discussion. We actually have a special session. We're going to talk about that. Okay. And with that, I'm going to go to our next presenter in our next part of our day and move into, and then we'll have Stephen Coring talk, and then myself, and then we'll take a break. So our next speaker is Stephen Coring. He's a professor in the Atmospheric Sciences program at Department of Geography at The Ohio State University. He's a fellow at the Risk Institute at the Ohio State University Fisher College of Business, and a core faculty member of the Translational Data Analytics Institute and the Sustainability Institute. His research focuses on hydroclimatology, weather data analytics, and modeling the impact of storms on electrical infrastructure. And with that, Stephen is joining us virtually today. So I go ahead and give it to you, Stephen.
Good morning. Thank you very much for this opportunity to present, and thanks especially to all of the organizers of this workshop. It is one of my favorite
Hold on a minute,
events.
Stephen. We cannot hear you. So we're going to get Mike to help us with technicals here.